So this video is going to be a problem that is a little bit more challenging. And the reason this one's a little bit more challenging is because this is a fourth degree polynomial. And we need to get this down to a quadratic to be able to solve for the last two zeros. So there's a little twist in this question. So again, highest power is 4. So the degree of the polynomial is 4. How many zeros, both real and complex? Again, those two match. So this is also going to be 4. So we're going to be looking for 4 zeros here. So let's go back to our rational roots theorem and figure out what our rational roots are. So the ones that show up on the graph are our rational zeros. So we need our P and Q factors. P is 18, Q is 1. So P is 18 and Q is 1. Write that so you can see that. 18. Again, P and Q. So all the factors of P, again, these are positive and negative. So we have factors of 18. Factors of 1 are just 1, so we don't have to have a denominator here. We have 1, 2, 3, 6, 9, and 18. So we need to go to our graph and see which one of these factors here are zeros. We're probably looking for 2 because we need to get this down to a quadratic, so we're going to have to do synthetic division twice. So if we do this in the graphing calculator, you can put these in the graphing calculator's table and see which one of these values gives you 0. So P of something has to give us 0. Let's go check out Desmos and see what we get. So if we come over to Desmos, here's our graph. You can see I already put it in. And we can then go ahead and click on our zeros. And that's -3, and that's +3. So our two rational zeros are -3 and 3. So we know that P of 3 equals 0, and P of -3 is equal to 0. So we have 2 of the roots, but we're looking for the remaining 2. So let me move this up a little bit here. And we need to now bring our polynomial that was fourth degree down to quadratic. So we have to perform synthetic division. So let's use 3. And we need our coefficients. Our coefficients are, I need to go back up and look. Our coefficients are 1, 1, -7, -9, and -18. 4, 3, 2, 1, 0. So nothing missing, so we can just write those down. So we have 1, we have 1, then we have -7, and then we have -9, and -18. Synthetic division, we're going to drop down our 1. 1 times 3 is 3. 3 plus 1 is 4. 4 times 3 is 12. 5, 15, 6, 18, and we get a remainder of 0, which is what we want. So this is now a cubic. So this would be x to the third, x squared, x, and our constant. So we need to perform synthetic division one more time to get it down to an x squared. So we're going to use our other 0 that we found, which was -3. So our new coefficients are off of the last one that we just did, 1, 4, 5, and 6. So synthetic division gets us 1, 1, 2, -6, and a remainder of 0, which is what we want. So now we have a quadratic, x squared, x, and our constant. So we have x squared plus x plus 2. And we need to solve this for our other zeros. So this is not a problem we're going to use completing the square with because our b value is odd, and we're going to have fractions. So we're going to do, and this is not going to be factorable because we know they're not real, the answers aren't real, so we're going to use the quadratic formula. So if you remember, the quadratic formula is the opposite of b, plus and minus the square root of b squared minus 4ac all over 2a. So I'm going to find the b squared minus 4ac portion first. So b is going to be 1, a is 1, and c is 2. 1 squared is 1. 4 times 1 times 2 is 8. So we get negative 7. So our zeros here are going to be x is equal to the opposite of b, which is negative 1, plus or minus the square root of negative 7, divided by 2 times a. A is 1, so 2 times 1 is 2. And we can simplify this out as negative 1 plus minus I square root of 7 all over 2. So here's 2 of our roots right here. And our other 2 roots are 3 and negative 3.